When Lando Norris, the reigning Formula One world champion, looks a journalist dead in the eye and says, "We are not very close to Ferrari," you stop what you're doing and you listen. When Max Verstappen finishes over a second behind in preseason testing and starts calling these new cars Formula E on steroids, you know something has rattled him to his core. And when George Russell goes on camera and openly speculates about the size of Ferrari's Turbocharger, a rival team's engine specification, you realize the entire paddock is obsessed with one single question. How on earth did Ferrari do this? The Scuderia just put the fear of God into every team on the grid, and the season hasn't even started yet. On the final day of Bahrain preseason testing, Charles Leclerc posted a 131.992, 9/10ths faster than world champion Norris, over a full second clear of Verstappen, the only driver all week to break the 132 barrier. But here's what makes it even more extraordinary. He did it while visibly wrestling the SF26 through corners, the car snapping and sliding like it was trying to throw him off. At one point, Leclerc waved his hand in frustration inside the cockpit after an aggressive slide through turn 11 forced him to abandon what felt like an even faster lap. The 131.992 wasn't the ceiling, it was the floor. And this wasn't some one-lap glory run. Leclerc completed 132 laps on that single day alone, including a full race simulation in 35-degree Bahrain heat. Trackside journalists described the long-run pace as not far off the best data posted by any team all week. Fast, consistent, relentless. But the lap time is only part of the story. What makes this result so fascinating is not just how fast the Ferrari SF26 went, it's what Ferrari sacrificed to build it, the radical technology hiding inside it, and the reactions from every rival team principal and engineer who watched it happen from the Bahrain pit wall. The raw numbers are striking enough. Norris was second at 132.871, a gap of 879 thousandths. Verstappen third at 133.119, Russell fourth, 1.2 seconds off the pace. The rest of the field scattered even further back. Yes, the tire compounds varied, yes, fuel loads differed, but you do not accidentally end up 9/10ths ahead of a world champion. Even after adjusting for the compound difference between Leclerc's C4 tires and the C3s used by Norris and Verstappen, worth roughly 3 to 5 tenths per step, the margin remained substantial. And it wasn't just the single lap that raised eyebrows, it was the trajectory across both test weeks. First test, Leclerc posted a cautious 134.273. Second test, he was into the 133.6 range. Final afternoon, he dropped into the 131s. That is a team methodically unlocking performance on purpose, not a fluke, not a glory run. The way rival teams responded tells you even more than the timing sheets. Norris, usually the last person to concede ground, told reporters plainly, "At the moment, we are not very close to Ferrari. We are not bad, but we are not fast enough." Then he said something even more revealing. He pointed out that Ferrari appears to have a deployment advantage, the way their hybrid system delivers electrical energy through the lap. His exact words, "When someone just has a deployment advantage, that is just a beautiful bit of lap time to have in your pocket. Without trying, you can just go quicker." Read that again. The world champion is saying Ferrari's car produces lap time the driver doesn't even have to work for. That's not a setup tweak, that's a fundamental engineering edge. Verstappen took a different approach, redirecting his frustration at the new regulations, calling these machines deeply unsatisfying to drive. But the subtext was impossible to miss. His own technical director, Pierre Wache, publicly stated, "We clearly see the top three teams, Ferrari, Mercedes, and McLaren, are in front of us." When your own technical director names 3 teams ahead of you before a single race lap has been run, that is not sandbagging. That is brutal honesty. And then there was George Russell, who dropped perhaps the most fascinating technical clue of the entire test. He openly speculated that Ferrari seems to run higher gears than other manufacturers, and that this probably suggests they have a smaller turbocharger. Drivers almost never go on record guessing at rival engine specifications. The fact that Russell did tells you Mercedes has been studying Ferrari's data obsessively and is struggling to understand what they're looking at. So what exactly is inside the SF26 that has the entire paddock talking? There are 3 specific innovations that set this car apart, and each one feeds into the others in a way that makes the whole package extremely difficult for rivals to replicate. The first and most visible is the rear wing. Every 2026 car runs active aerodynamics. The rear wing opens on straights to reduce drag, closes in corners to maximize downforce. Standard stuff. Ferrari took that concept and pushed it to an extreme that nobody else dared attempt. Their upper rear wing element doesn't just open flat, it rotates 225 degrees, essentially flipping almost completely upside down, the convex surface facing skyward like an inverted aircraft wing. The effect is dramatic. In straight-line mode, the wing creates an aerodynamic stall that slashes drag far more aggressively than any conventional system on the grid. Hamilton reportedly gained 10 kilometers per hour on the Bahrain straights when the wing deployed. Technical simulations show the wing achieves roughly a 75% drop in rear downforce when fully open. The FIA confirmed it's completely legal. Technical Director Nicholas Tombazis stated that the FIA has, generally speaking, encouraged solutions that reduce drag. But here's why rivals cannot simply copy it for Melbourne. Ferrari didn't bolt this wing onto an existing car. They redesigned the entire rear end around it. The differential is positioned the maximum 6 centimeters rearward of the axle line, creating space for an extended diffuser and an exhaust-powered device. The rotating wing, the diffuser, and the exhaust device work as one integrated system. You cannot copy one piece without rebuilding everything behind the gearbox. The second innovation is arguably even more significant, and it's hidden deep inside the power unit. With the new regulations eliminating the MGU-H, the motor that used to keep the turbo spinning between gear shifts, every team now relies purely on exhaust gas to spool their turbocharger. Ferrari made a calculated bet. They chose a smaller Garrett turbocharger than their competitors. A bigger turbo makes more peak power, but takes longer to spin up. A smaller turbo spins faster, builds boost quicker, and demands less energy to get going. The payoff was immediately visible, not on the timing screens, but at the practice starts. Hamilton launched the SF26 from 5th on the grid and rocketed past cars that had lined up ahead of him, including Kimi Antonelli's Mercedes and Verstappen's Red Bull. It wasn't even close. Hamilton was alongside and passed before they had fully engaged second gear. This happened every single time. Not once, not twice. Every practice start, the Ferraris launched like they had an extra engine bolted to the back. On the final day, Leclerc sent George Russell defensive into turn 1 in front of the entire paddock. Wache confirmed what everyone suspected. Clearly, in low-speed traction, they look very strong. That was the diplomatic version. In a sport where races are decided at turn 1, a consistent launch advantage isn't just useful, it's potentially championship-defining. And you can't match it with a software update. You'd need to replace your actual turbocharger, which means redesigning your entire power unit packaging. The third innovation is a small aerodynamic vane positioned behind the exhaust pipe that redirects hot gases upward into the underside of the rear wing, effectively supercharging its efficiency while simultaneously energizing the airflow exiting the diffuser. Combined with the mouse hole opening spotted in the lower bodywork during testing, the entire rear end of the SF26 is one cohesive aerodynamic philosophy. Every component talks to every other. The total effect is greater than the sum of its parts. None of this technology appeared out of thin air. To understand how Ferrari had these innovations ready while rivals didn't, you need to understand the most controversial strategic decision in recent Formula One history. In the spring of 2025, Ferrari team principal Frédéric Vasseur made a call that shocked the entire sport. He stopped developing the 2025 car completely. Not scaled back, not reduced, stopped. By late April, Ferrari had effectively abandoned their current season and redirected every engineer, every wind tunnel hour, every resource towards the SF26. The consequences in 2025 were brutal. 0 Grand Prix victories, 4th in the Constructors' Championship, 435 points behind champions McLaren. Their worst season in years and entirely self-inflicted. Vasseur took full responsibility. "It was my decision," he told the press, "and I take full responsibility." Perhaps I also underestimated the psychological impact of this choice on the team, on the drivers, and on myself. That level of honesty from an F1 team principal is rare. It tells you exactly how painful that year was.